All right, folks. So I'm going to give a talk about the many ways to deploy continuously. As was pointed out, Alan was supposed to give this talk and rather selfishly went off to Italy on his honeymoon. And so, fortunately, I kind of know the material pretty well, and I as well. So Alan and I are co-founders of a company called CircleCI. CircleCI does hosted continuous integration and deployment for Ruby apps and also Node and similar kind of apps. So we have a couple of thousand developers who are as our paying customers, and about, I think, 42% of them are doing continuous deployment. So we get to look at a lot of people who are doing various kinds of continuous deployment. And then we also spend a lot of time looking at what the future of our product is going to be by looking at what all the big guys are doing. So looking at what Facebook is doing, looking at what Etsy is doing, ImVU, GitHub, that sort of thing. And so this talk is kind of about what we've learned during this kind of research and talking to our customers. So most talks that I give, and I guess most talks that you're used to coming to, are all about giving answers. And this is not one of those talks. I'm not here to tell you the right way to do continuous deployment, because I think one of the things I learned is there is no right way to do continuous deployment. Everyone we talk to does continuous deployment ever so slightly differently. From the guys who only do continuous deployment at 9 to 5 Monday to Friday, except Friday afternoons because that's beer time, to the guys who only do it at 2 a.m. because that's the only time they can stand their caches being cleared. So I think that if you're doing continuous deployment, or if you're going to do continuous deployment at your company, there is probably a way that you think that continuous deployment should be done. And I think that if you look at other companies, they will all be doing it completely differently. And so what I'm trying to do here is, instead of giving you answers, to talk about the variables, all the different variables that are associated with doing continuous deployment. These variables can include the speed at which you're writing new features, the complexity of your code, the design of your software and the architecture of your software, whether you're doing service-oriented or whether you have a sort of a monolithic kind of app, and even things like business priorities, the number of engineers you have, and the state of your monitoring. All of these will affect how you do your continuous deployment. So the talk, or most of the talk, is actually about deployment, because continuous deployment is a subset of all deployments. A lot of the problems that you face with deployment aren't really problems if you only deploy once a month. You can have a minute of downtime every time you deploy and still have 4 nines of reliability. But there's these problems that you get with deployment, which only really become a problem when you're deploying 10 or 40 or 500 times a day. A lot of times deployment is really, really hard, even on your day-to-day deployments, but you only really start to notice it when that happens every few minutes. So I want to quickly go back to kind of the early days. I'm sure people here will remember when they used to deploy PHP to a shared server using FTP. So this is kind of the original deployment on the web. And the way that it worked was you had your code on your server or on your own machine, and you wanted to get it onto your web server. And that's kind of the basics of deployment. Your code is here, it goes there, and there's a transport, in this case FTP. There's also a server on the far end, and you need to coordinate with your server to decide when you switch from the old code to the new code. In the PHP days, what happened was the server just stayed up and running. All the logic was in mod PHP, and it was in Apache, and so you could overwrite the PHP files, and you would have absolutely no problem at all. The server would just keep running. But even though it's very straightforward, what happened when requests came in, web requests came in from your users while the deployment was happening? There was this period of time when files were being overwritten, and half of the files had been copied, and half of them hadn't been copied. And so you got users who would start a page, I guess, start a request that goes through code that is new, and then got passed into code that is old and didn't have functions that you would expect it to have. And so this is the problem with every single deployment that's out there. Everyone who's doing deployment of any kind or continuous deployment of any kind has this race. There is old code, there is new code, they are different, and you're still getting requests while these things happen. So the downtime was something which kind of happened in the 90s. But now, there are no maintenance windows. There's no planned downtime. That stuff isn't really allowed anymore for your users. And so every single time you have this deploy, you're going to have a race. The way that we dealt with this in the PHP days, the advanced deployments use symlinks. You would upload your code into one directory, and your old code was in another directory, and once it was all uploaded, you would change the symlink and atomically point to the new directory. And I say atomically because there were requests in flight probably at the time, which were still affected. So even more advanced people would shut down taking requests for a couple of seconds, then do the atomic switch, and then continue doing requests. So it seems like that kind of has the problem solved. Except the race appears in many, many different places. So it's not just in changing from one version of the code to the other. It's DB schemas. It's API versions, asset versions, anything that has a service running on it. If you change that service and it interacts with another service, maybe those versions get out of sync. So let's talk a little bit about a more modern world, one in which we're running on Heroku. So it's basically the same elements as an old PHP version. You're pushing code. It's got a different transport, Git over SSH. But it's fundamentally, you're pushing new code, and there's old code, and there's a transition to be made. So when you push and users are making requests, what happens? Well, Heroku, I guess, intelligently routes your data to a new dyno. No. So Heroku basically makes your requests queue up, basically exactly in the same way as it was in the PHP days. Requests queue up, and then the new code handles it. So when the new requests come back, those were requests that were made by an old version of your app. Your users are running code which was generated by your old version, and that code is now calling back to your server, and it's hitting new code. So your new code has to expect that. It has to expect to be able to answer the questions that the old code was asking, and to answer them in a sort of a similar way. Your new code is also connected to the old databases. If your old code, or if you need a schema change between switching to your old code and your new code, then you have to run that migration sometime. And if you're running that migration, then your old code needs to support the old schema and the new schema, or your new code has to support the old schema and the new schema. And so you need to write your app to take that into account. The alternative, and this is going to be a recurring pattern to solving all of the continuous deployment problems, is to make sure that you deploy an intermediate version, something which understands both the old version and the new version of, in this case, the schema, but in anything which has different versions. You deploy something, try to get it fully deployed that supports both the old and the new version, and then you can do your migration, or you can do your version change, or you can do your database upgrade, or whatever it is. So this is starting to sound pretty good. We've got kind of a solution, even though I said I wasn't going to offer solutions. Here's a solution. And this is kind of where problems start really to go to hell, because once you've solved this, there only remain really, really difficult problems to solve. And two of them that I'm going to talk about now are data migrations and table locking. So when you're changing your data, or when you're changing your schema, you're affecting generally only your schema. You're not affecting the data, and sometimes you need to do a data migration as well. And ImVU, raise your hand, quick audience participation time, if you've heard of ImVU. Okay, excellent. That means that my talk is not, that means I'm not talking to people who already know all of the stuff that I'm going to talk about. So ImVU is the company that essentially created continuous deployment. They were the first people doing it. They pioneered basically everything. They even coined the term continuous delivery. That came from a guy who worked at ImVU. And it's a startup that's founded by a guy called Eric Ries, who is the main proponent behind Lean Startup. So it's all about iteration, continuous development, continuous deployment, continuous delivery, that sort of thing. So there's the problem when you change your DB tables, that the tables will lock. If you add a new default column to your table, and you have a lot of data in that table, then you can't expect to see your table again for another couple of hours. And your site is down, and your users are down, and things are complaining. And this is very awkward, obviously, if you're running a business like most people. So what ImVU did is that they decided that they were never going to do a schema change on their SQL tables. And what they did instead is, instead of having a user table, they'd have a version table. So they'd have user 37. And whenever they need to change the schema of user, they would create user table 38. And that user table 38 has the new schema. And that way, they never actually change a table that's in place. Whenever they go to look for a user, they'll look in user 38 first. And if they don't find it there, then they'll go to user 37, take the data, do whatever data or schema migration they need to do to it, and then copy it over. In the background, they have a process running which slowly moves everything from the old table into the new table. And so what they meant to do there is they meant to split out those schema changes to do it row at a time instead of entire table at a time. And that way, they avoided the entire problem. Another way to do it is to use something which has no table locking. So MongoDB, I was going to say, has no table locking. It has its own horrific locking problems. But any sort of schemaless database you have will not have the schema migration problem that you suffer from. So you may have to assume that all values do not exist, but you can't assume that fetching an old value or expecting an old and a new value, well, basically, the problem goes away or vanishes. So Facebook doesn't actually do continuous deployment. They're still old school. I think nowadays they deploy once a day. But they had to solve the same problem, which is that they have a huge amount of data. They solve it the same way that ImVU does it, by running all these background processes. But those background processes to migrate old data to new data can take months sometimes. Facebook has a lot of data. So what they do is that they write the code to assume that it can have the old data. They have big if statements and switch statements that say, if version is this, assume that the data can look like this, or like this, or like this, or like this. And often, if it takes months for your data to migrate, then you sometimes have to just assume that it's going to take months for those if statements to actually leave your code. And that's the way they do that. So I want to talk a little bit about how to deploy code, because it seems like something it's kind of obvious. You push to Heroku or something. Code must be deployed to every new machine. And there are ways of getting code. There's basically two ways of getting code to new machines. You can build your entire code package in advance and deploy that image to your new machine. Or you can have every machine that you want to start up take the code and build their own image as they go. And there's advantages to each. So the first is shipping an image. If on your continuous integration build, or on your local machine, or on a special machine, or wherever, you take your code and you get all of its dependencies, you build all of its assets, all of its generated files, anything that you need to do, you generate it into a package and you put it somewhere. So this is fundamentally what Heroku does with their slugs. Whenever you push to Heroku, it'll take it on its Git server, it'll download all its dependencies and gems and all that sort of thing, and compile them into what it calls a slug, and then deploy that slug to each dyno. And as you scale up, it'll just download that dyno again and not have to do a recompilation, so it can scale up very quickly. And you can do this yourself as well. You can do it on an AMI. You take your base image on Heroku, that's kind of equivalent to a build pack. And you put your code and your dependencies on it, and you create a new AMI. And you let Amazon automatically scale you up and down, and your code is already on that machine. And there's middle grounds as well. You can take things, put them into a tar gzip and put them onto S3, and then download that when the server starts. So all of these are kind of roughly the same. You take an empty server, and you kind of go for it. Empty server, put an image on it, we have a new server. But whether or not you want to do that or not depends on your deployment strategy. When you push new code to production, what do you want the machines to do? And there's two strategies here. Is the new code that you want to run on all future machines, or is the new code something that you want to replace all existing machines with? And it depends on how fast you scale, whether you go up and down a lot. And so I think it's kind of an interesting problem. It also, if you think of only putting code on future machines, then you're acknowledging implicitly that races will always be a part of your life in the future, that you may have half a day or a full day of races. And I think that can actually be quite freeing. So I want to tell you about the way that we do it at Circle CI. So we run continuous integration builds. Our customers push code to GitHub. GitHub sends us a notification, and we run the builds across dozens of machines and that sort of thing. So the way that it works is that at night in California, we are running very, very few builds. The nature of selling to developers means that a lot of them live in America, a lot of them live in Europe, and the rest of them are kind of interspersed across the rest of the world. So when it's nighttime in California, Europe hasn't got to work yet, and we only have a much smaller version of or number of customers in Asia. So kind of nothing's really going on. The system is quiet. And then Europe wakes up, and then the East Coast wakes up, and then finally California wakes up at the same time that Europe is hitting its peak pushing time, which is 4 p.m. And as you go through that 10-hour period, we go from nothing to our peak. And then, as California goes back to bed, we do it again. And what this means is that new code only makes it to new machines. We don't have the luxury of turning off old machines whenever we deploy new code, because we need those machines to run the builds that have just come on. It's pretty expensive running builds for people, so we can't just turn off machines willy-nilly. There's a lot of kind of downsides here. It means that we can't get our code to customers very quickly at all. We do it essentially the same day, and we have a kind of a back door where we can over-provision, and that'll shut down the old machines. But it's not the sort of thing we want to be doing all the time. So whenever we push out code, we'll know generally that we have to wait about half a day to get code in certain subsets. So web code we can get out much more quickly. So if you had an embarrassingly parallel problem like web servers, you can do it a lot better. And you might be better off deploying from Git. Instead of creating an image and bringing that image down onto new machines, like we did, you might be better off if each machine could upgrade itself. Whenever there's a new version, wait a random amount of time, shut down the web server, remove yourself from the load balancer, do a Git update, do a bundle update, and start the web server up again. Connect to the load balancer and your queues and whatever else you do again. And you can do that because you're not relying on any of this, like we are, where you have to kind of go up and down, and there's very tight constraints in the amount of machines that you want to run. So they can do rolling restarts without really taking the servers down at all. And this is exactly what Twitter does. So Twitter has a system called murder. Murder as in a group of crows, not homicide. And so this is what they said about their system. We used to have a Git-based deploy strategy where we just instruct our front ends to download the latest code from our main Git machine and serve that. Unfortunately, once we got past a few hundred servers, things got ugly. So I'm sure most of us in this room aren't at the few hundred servers or a few thousand servers like Twitter is, but the problems can happen at a kind of a small scale as well. So the way Twitter did it is they moved away from a centralized system like Git, and they moved to a decentralized one. And the decentralized one that they used was BitTorrent. Now, whenever they deploy using BitTorrent within their data center, where BitTorrent is shockingly fast, and it's decentralized, of course. So their 40-minute deploy, which is how long it took for new code to reach every machine, is now 12 seconds. 12 little seconds. So you might be familiar with the new Shiny, which is what I'm using to refer to one-page JavaScript apps. You take all of your JavaScript, all of your views, everything, and you you ship it as an asset, and then it interacts with APIs. So this is very common. We do it. It's brilliant if you're a developer. But it leads to a whole new interaction problem, which is the asset race. It's the same race again, but now it's with assets. So you kind of end up with this situation where the code that you deployed 3 weeks ago is still hitting your server because someone went on holidays or they had the tab open somewhere. And you end up, again, with kind of races. And if you've ever used Trello, then you might have seen their solution pop up every few days. There's a new version of Trello. Click here to do it. There's the problem in reverse as well. You've got new JavaScript code, and you ship the new JavaScript code, which expects an API to be there, but the API hasn't fully rolled out to all of your systems. Same fix for that as before. Roll out your new code before you roll out the code that relies on it. So everything so far has been about deployment, and not so much about continuous deployment. But if we hit all of these problems in manual deployment, surely continuous deployment is going to be absolute hell. And there's two ways that people deal with this, and those are monitoring and testing. Testing is really difficult. It's not like you can create a unit test that says there was this version and there will be this new version, and we'll test both versions of our code base in the same unit test. Your test runners aren't exactly run that way. So, and even if you could get it working, it's not like you could write tests to anticipate what goes wrong, because the problems tend to happen when you put it in front of customers and customers click around and 3-week-old versions of code are hitting it in ways that you don't expect. So what people tend to do is they tend to do the conversion on their dev server, on a staging server, something along those lines, and then they try to figure it out. So GitHub goes one step further. At GitHub, all code that gets merged into master must first have been in production serving actual customers. So in this way, they protect master from code which isn't quite ready to go out, so that master is always ready to go out. And they ensure that all code will have been tested against a small number of users before it's tested against all of the users. So I personally think that this is a great idea, and it's something which is going to be incorporated in all our workflows within the next couple of years. Facebook, similar problem, or similar solution. All code goes out to all customers, but new features are disabled, and they're disabled by feature flags, which can be very powerfully enabled. So they can do something like enable this feature, but only for married women aged 25 to 27 who live in Northern California and have a dog. And so this enables them to show new features to tens of people, and then to hundreds of people, and then to thousands, and eventually to millions and hundreds of millions of people. And so that they can test against a very small number of people before they test against a huge number. So that's testing, and that's how people do it. It's pretty cool. And the complementary technique to that is monitoring. So I'm sure all of you do monitoring for your systems. You get kind of dragged out of bed if your database spikes to above like 300 milliseconds or something like that, or if your rate of exception increases or something. But ImVU took it quite a bit further. Anytime that they had a problem in their continuous deployment system, they added it to monitoring so that they'd be able to automatically roll back. And that includes business problems. So they had a problem which I refer to as the white-on-white problem. They deployed a white buy button onto a white background, and even though the code worked, nobody was clicking on the buy button because they couldn't see it. So obviously their conversion rates plummeted as people didn't know to click the button. And to solve that, they added business metrics. And anytime that business metrics or any other metrics go terribly wrong in the 10 to 15 minutes after they deploy, it's automatically rolled back. So I think it's kind of easy to see how we can do that. We can look at more than our monitoring systems, or more than technical systems for being monitored, and we can start looking at conversion funnels, how far people get down the funnel, how happy people are. All those key performance indicators for our business can also be used in our continuous deployment system. So that's kind of the end of my talk. Thanks very much for listening. It covered a lot of ground about different ways that people deploy and the challenges to deploying continuously. If this sort of thing interests you, Circle CI is hiring. Jobs at is our address, and that's manned by me. So I'd also love to hear from you if you've any ways if there's any ways I haven't covered in which people do deployment continuously or not. Very interested in the sort of things around efficient transport mechanisms, reducing problems with deploy time racings, and all sorts of kind of database schema locking. So I hope that you guys were all interested in this sort of thing as well, and enjoyed hearing about the many ways to deploy continuously. Thank you.